Okay, welcome, good evening, everyone. Welcome to this live session. Today we'll be talking about Solidity installation, installing and setting up your local environment so that you can do smart contract development on your machine. And also, we are going to be writing some basic smart contracts and also get to know what a smart contract entails. We learn about the life cycle and other basic stuff of smart contracts. Okay, so for the development, we are going to be using hardhat. So for this start, I'm not going to be using VS Code directly. So because some of us are actually not using VS Code on our own machine. Some of us are using maybe Sublime Text. So what I'm going to be doing is that I'm going to be opening my file manager. Then inside the file manager, I'm going to open, I'm going to create a folder. So this folder is going to be the folder where our project is going to reside. So I'm going to name it. You can name it your own any name. So I'm going to name it Block Games Solidity. Yeah, something like that. Okay, yeah. So after that, then you can right click and open your terminal on Windows. You can open it in command line. So I'm going to open it in my terminal. So now that we opened it now, so what I'm going to do next is actually for you to have to be able to set up this local environment, you need to have Node.js installed. So Node.js is basically just a JavaScript. So you can execute JavaScript code on the server. So you can go to Node.js dot okay, so you go to nodejs.org to download the Node.js on machine. You can use you can select the LTS version or use the current version. So I have it installed already, so I don't need to do that again. So okay, I've opened the folder on my terminal. So what I'm going to do next is run npm init to initialize our package. So npm init -- yes. So it accepts everything. So the next thing I'm going to be doing is installing hardhat itself. So we do that by saying npm install hardhat. Then you just want to install it in only this want to install it as a local um, development dependency. So we're using this flag save dev. So let's wait for it to install. So hardhat is installed now. So next thing we need to do is to initialize our hardhat project. So to do that, we need to run npx hardhat. With this, we are going to initialize our project. So you see a screen like this. So you can there are a couple of options that you can select: create a sample project, an advanced sample project, an advanced suite that uses TypeScript, or you can just create an empty hardhat config file. So we are going to be creating a sample project. So then you can just continue pressing enter, and so it's going to automatically install some dependency, some hardhat plugins, and some dependencies that you need to set up your basic project. Okay, yeah. So with the project has been created now, and the hardhat project has been set up. So I'm going to close this terminal. So I can just open it from open my VS Code from the terminal directly, but for those using Windows, it might not be easy, and I know some of us are actually not familiar with all this thing. So I'm going to just right click on it on the folder that that contain our project. So and click on open with other application. So on Windows should have something like that too. So I can choose to open with anything, Sublime Text or any other thing, but I'm using VS Code. So I'm going to open with VS Code, and that should open now. Okay, yeah. So our project has been opened in VS Code. So okay, so let me zoom a little bit. Send this to be. Okay, so I'm going to open the integrated terminal. So you can like click on the sidebar here and open in integrated terminal VS Code. So before we continue, there's a VS Code plugin called Ethereum Remix. So if you come to this extensions section, you see you can search it Ethereum Remix. Then you can install it from there, Ethereum Remix. So I have it installed. I don't need to do that again. So that extension makes it possible for us to run our smart contract directly in our VS Code instead of going to do that on Unix. And with that, we don't need to connect to a remote node. We can just spin off a node on our machine and connect directly from the VS Code remix. Okay, yeah. So let's see the anatomy of the hardhat the whole hardhat project. So you can see that we have a README file. So basically, we all know what a README does, just details or description about the project and couple of any other thing. So then we have the package.json file. So this is where our dependencies list live. So you can see that we have dev dependencies, that's the dependencies that we installed. And some inside dependencies, you can see that we have some hardhat plugins and other Node.js dependencies. So we have the hardhat config.js file. This is the configuration file for our hardhat project. So whenever we need to do whenever we need to change some configuration, we can do that here. So we also have test directory. So this is where we write our smart contract tests. So if you deploy a smart contract, you can write some tests for it to test whether everything is working fine. Then we also have the scripts folder. So the scripts folder contains some utility scripts, like let's say your deployment scripts. You need a script to do basically it's just any valid JavaScript file is a script. So it can be anything, basically. So then we have the node modules. We don't know what that does. Contains the Node.js, the installed dependencies. So they reside in this Node.js, in this node modules directly. Then we have the contract, and that's where we are going to be doing the majority of the work. So inside this, this is where we write our smart contracts. So whenever we need to write any smart contracts, we just go to this contracts folder and write it. And then, okay, so hardhat comes with a sample smart contract called data. So I'm just going to like go through this smart contract. I'm not very good. So you can see this is a basic smart contract. The name of the smart contract is Grita. It has a state variable which is private, and it's also a string. The name of the variable is greeting. Then it has a constructor which accepts one argument parameter. Then we are inside the constructor, we are assigning the parameter that the argument that we are passing into the constructor. We are assigning it to we are setting the state variable to it. So we are still going to be learning more about what state variables are and stuff like that. So we also have a function which returns the state variable, which is also public, and it also has other modifiers that you can see. So we also have the last function, which is set greeting. This is a setter function. It sets our blockchain state, so our smart contract state variable greeting, to whatever is passed as an argument. So you can see that here we have a pragma statement. It's a directive for us to tell the compiler what version of Solidity to use when compiling the smart contract. Then we also have this one up here, which is the SPDX license identifier. This is there for us to specify the license that we are using, that the project is using. So this license can be MIT, can be any other MIT, can be any other license too. Okay, so yeah, I think we should just run this smart contract first. So what I'm going to do now is okay. So hardhat, I think we should just do okay, I have a separate video on that on YouTube. You can, if you want to learn more about deeply about hardhat, I have a video there's a video on the Zuri team channel where you can learn about hardhat. And so this, okay, so hardhat comes with a built-in blockchain called the hardhat network. It's a fake blockchain, so we do not need to separately install any other blockchain, any other fake blockchain software like Ganache and any other similar software too. So basically, whenever you run your hardhat project, you deploy or you test, the blockchain, the fake blockchain runs in the background. So you don't even know whether it's running or not, but it's actually running in the background, and you don't need to do any other thing apart from that. So, but here, what we are going to be doing is we want to spin off a node. So basically, also hardhat comes with a feature that allows you to run a blockchain node directly from the command line. So to do that, we just need to do npx hardhat node. So once we run that, a node will be spin off. As you can see now, as you can see here, started HTTP and WebSocket JSON RPC server at HTTP 127.0.0.1, then the ports and other blah blah blah. So these are the accounts and private keys that it generates for us that we can use with the blockchain, with the node that's pinned up for us. Also note that everything in this node or everything in this fake blockchain is actually not real. You cannot say you want to send this 10,000 ETH to mainnet or any other network. So basically everything ends on this on your machine. So whenever you spin off a node, you get another set of addresses, and they're also going to be refilled with 10,000 ETH balances too. So that's about that. So for the remix, so once you install the remix extension on your VS Code, you should see this. Whenever you open the Solidity file, you should see this. So you can click on it. So and wait for it to load. Okay, yeah, so it's loaded now. So now that it's loaded, we can click here on run and deploy, because we want to test out this smart contract that comes with hardhat. So run and deploy. So we activate. Once you click on it, it's going to tell you to activate. So I'm going to move this into this main stuff here. Okay, now that we've opened that, so we want to connect to our local blockchain. So if you come to this terminal here and you come to this up here, you see that the node is running on on port 8545. So what we just need to do is like copy the node URL here, the local node URL here, and paste it here, and then connect here. So actually, you can also connect to Remix from this extension too. So, but since we have our local blockchain, our fake blockchain, we can just do it from here. Okay, yeah, so we have that now. So as you can see, we can see some logs here, say account, adding network, getting account, stuff like that. So okay, I have some deployments there, so let me delete everything. Okay. So as you can see, these are the accounts that were generated for us by the node, by hardhat when we spinned off the hardhat network node. So you can just choose, you can click on any account. Each account is pre-filled with 10,000 ETH, 10,000 test ETH, not real ETH. So let's compile our smart contract. So before that, if you open, whenever you open any smart contract here, it's going to be automatically it's going to be automatically loaded in this drop down here. So let's compile it. So as you can see, it's loaded, compiling with the latest version, and still compiling.
So
our compilation has complete now. So let's check, let's deploy. So As you can see here now, in this smart contract, our constructor is accepting an argument. The name of the argument is written. So whenever I want to deploy a smart contract, the first thing that runs is the constructor. So if this constructor accepts an argument, you must pass the argument to the constructor when you are deploying. So let's pass in the constructor here. So the argument to the constructor here. So it's written. So let us say hello world and click deploy. So it's been deployed. So if you come here, we can see that these are our deployed smart contracts. So if you click on it, you can see that we have some buttons here. And so also, you can also, if you can see that we have a button called greet. So it has the button, and also set greeting. It accepts an input and the button too. So basically what how this actually works is that Remix takes your function, your smart contract API, and then it passes it, and based on the inputs, okay, don't let me go into that details, might be confused. So let me just stay at this smart contract level. So as you can see here that we have a greet function here. So what we are doing here is just that we are returning the blockchain, the greeting variable that we set in the blockchain storage, that's in the blockchain storage. We are just returning it. So exactly that's why we have this. What's it called? We have this. That's why we have this greet. Also because it's what's it called? It's just returning from the blockchain. It's a view function. It doesn't alter anything on the blockchain. It doesn't like update the blockchain state. So it's a view function. You can just call it. So you know that when we were deploying the smart contract, we passed in a parameter which we wrote hello world. So when we call this now, we should get hello world. So as you can see here, we got this back from the blockchain hello world. And that's because that's what we passed when we were deploying the smart contract. We passed it to the constructor. Then we have, if you check our smart contract again, we have another function called set greeting. So this function is actually updating the blockchain state, and it accepts one argument, which also greeting. So what we are doing in that function is that we are setting the blockchain state variable, which is greeting, to whatever we are passing here as an argument. So if we come to this to this remix tab again, and we come back to this set greeting, you can see that this is the name of the function that's actually in the smart contract, set greeting, and this is the name of the input or the argument that it accepts. And what the function does is that it updates our blockchain state. That's it updates the blockchain variable, which is in our smart contract, which is greeting. So, like we said before, that's the one our last state, our current state in the blockchain, we have the hello world as the greeting. So if you call it again, we should still get the hello world, because we should still get the hello world, because that's the current state of the blockchain. So if you alter the state of the blockchain now by setting the greeting to another thing, and saying hello there. So hello there. So click transact. So we are setting the blockchain state now. So the transaction is successful, and let's retrieve our blockchain state again. So as you can see now, the blockchain state has been updated. We now have hello there. And that's exactly how this remix works. So if you have any question about what I've been doing so far, you can drop them in the question in the chat section of the call. Okay, yeah, so what we are going to be doing now is we are going to be writing our first smart contract. So, like I said before, our smart contract, our smart contract is going to be living in this contract directory. So, and that's where we are going to be writing our smart contract. So let's create a file called firstcontract.sol. So we have that firstcontract.sol. Okay, yeah, so I'm sorry about that. Okay, so the first thing we'll be doing in this first smart contract is writing our smart contract license. So basically, every smart contract will be written, we must specify, is not, maybe not a must, but we should specify the license that your smart contract is using. So to do that, you need to write up here at the first line, you need to write SPDX license identifier. So we can set any license that we want. So basically, and normally I want to use MIT. So once we've done that, then the next thing is to tell the compiler what version of Solidity that it should use when it's compiling the smart contract. So we're going to do that with the pragma directive. So we say pragma Solidity, then we specify the version. So basically we want a version that's 0.8.0 plus. So that's why that's what we are telling the compiler here, that okay, so whenever I want to compile the smart contract, use this version of Solidity. So after we've done that, the next thing I'm going to do is create our contract itself. So we say contract, and the name. Then after we write this, the next thing you do is to write the name of the smart contract. So we are going to be doing that by saying first contract, that's the name of our smart contract. Then you add, you put the curly braces next. So this is a basic smart contract. It does nothing. It's just a smart contract. Nothing. It has no function, no variable, no constructor, nothing. Just an empty smart contract. So we don't want an empty smart contract. We want a smart contract that will be able to do something. Maybe do something. Okay, yeah. So for that, what we are going to be doing is creating a variable. So basically, a variable is a named location in memory. So what we do with the variable is that we store data in it, and that data is located somewhere in memory. So we give the location a name, so we can access it and use it any other place in our smart contract. So variables in Solidity have, so Solidity is a statically typed language, which means whenever you are declaring or defining a variable, you need to tell Solidity, you need to tell the you need to tell it what type is the variable. So if your variable is a string, you need to tell it that, okay, this variable is a string. If it's an integer, you need to tell it that this is an integer. Also, for integers, we have two types of integers. So we are still going to this here. So you need to tell it, if it's a boolean, you need to tell, okay, this is a boolean, and basic stuff like that. So In our case, what we're going to be doing is we are going to be creating a string variable. So we say we specify, like I said, it's a statically typed language. You need to tell it. So what we are doing here is we are telling it, okay, this variable we want to define, or we want to declare, or we want to create a string. Then what follows next is either to say, okay, is this variable going to be a public variable? Should anybody that's reading the smart contract, that's calling the smart contract, have access to this variable? Or the variable should just be accessible by the blockchain only? Or should the variable be only accessed outside of blockchain only and not inside of the inside of the smart contract? I mean, not blockchain. Yeah, still blockchain, but specifically inside the smart contract. So should the variable be accessible by anybody calling the smart contract? That's the public variable. So a public variable is a variable that anybody that's calling the smart contract can have access to it. They can see what's inside. So to do that, you just say string public. So we are telling, okay, this variable is not public. Then the next thing we do is to now specify the name of the variable itself. So the name of the variable in our case is going to be title. Then we end it with a semicolon. And that's it. We've defined our variable. So one thing about this variable is that this variable is a state variable. And what are state variables? State variables are variables that are written to the blockchain storage, which means that once this smart contract is deployed, this variable that will deploy that here is going to be available in the blockchain storage, and we can write to it, we can change it, update it, and do anything we want with it. So state variables are basically variables that are written to the blockchain storage, that are stored in the blockchain storage. So the next thing I want to do, or we want to do, is to create a setter function. So like the name implies, like the name suggests, a setter function is a function that sets something. So once our setter function to do what? To set this variable. So let's create a setter function. So what's a function actually? So a function is a reusable code. Is a group of code that's reusable in other parts of your smart contract. And basically, functions can be the entry point to your smart contract. So let me explain what I mean. So if I write this function now, so let me just if I write this function now, I can call this function anywhere in the smart contract, depending on depending on the visibility I give it or the scope I set it to. So I can set, just like variables, I can set I can set functions to be public, they can be private, they can be internal, they can be external. So a function is a reusable piece of code that can be used in any other place on your smart contract, depending on the scope you give it. So in this variable, in this function, we are going to be calling it set title. And so here, what we are going to be doing is that the scope of our function or the visibility is public. So anybody can call the function and execute the code that's inside. So we add the scope, which is public. So the next thing we need to add is the parentheses. So this is it. So, but once you update the blockchain, the smart contract state, which is this, want to update this title in the smart contract state. But how are you going to even update it? How are you going to get what we want to update it? Like, for us to update something, we need to get the whatever we are going to update it to, we need to get it. So that's why we have parameters or arguments. Let me just stick with parameters here, but if you are passing it, we are calling it arguments. So parameters here. So parameters are inputs. Let me just, okay. Parameters are inputs that are being passed to your block to a smart contract function. So for example, if I come here now and say string or say uint, let me just stick with string for now. String memory, then title. So this is the parameter. You can, some people call it argument. It depends on the context. You can call it argument or parameter, depends on the context or the angle you are looking at it from. So I'm just going, I might be using it interchangeably, parameter, argument, depending on whatever comes to my mouth. So this is a function parameter. So what we are going to be doing here is that we are going to be setting this blockchain, this smart contract state variable. We are going to be setting it to this parameter that we are passing into the function. So to do that, we are going to say title equals the parameter that we are passing, which is title. So you can notice another keyword there, which is memory. So memory, basically in Solidity, we have variables are stored in different locations. So like I said before, we have they can be stored in the smart contract storage here, which are their state variables. So then we have memory. So basically this this memory indicates that this variable that parameter that are passing to the smart contract is going to be stored inside in memory, and whenever this function finish executing, it should discard whatever is here. So this variable actually is not stored in the construct storage. So also for us to use there are other type of memory of location that we can actually indicate. We have call data. We are still going to use it. We have call data and other like that. So, but let's just I'm still going to like explain what this memory mean later as we are going. But let's just stay with it like that for now. So another thing you notice is that I'm adding an underscore before this title. So the reason I did that is because I don't want, if I remove it now, you see that this and this are the same name, like title. So I don't want this to interfere with this. So that's why I just added this underscore, and you can call the parameter any other thing as long as it doesn't mean this. It doesn't it's not the same as this. So, but it's a convention to add an underscore before it. So as we are okay, let's continue. So we are setting the title, which is a blockchain state, the state variable up here. So yeah, I think that's all about this for now. So the next thing we need to be doing is a getter function. So basically, Solidity for public variables, Solidity automatically creates a getter function for them. So even without creating a getter function here now, we just create a setter function here, and we are doing nothing apart from that. So let's try to deploy our smart contract. So we can select that here. As you can see, we have our contract here now, first contract.so. So let's compile it. So the compilation is complete. Let's deploy it. So now it's deployed, and you can see the smart contracts, the deployed smart contracts here. So as you can see here now, we have the functions that we created in our smart contract are passed and converted to a UI for us to interact with the smart contracts here. So as you can see that we have this title here. And basically, the reason that happens is because Solidity automatically generates a getter function for public variables. So it's not a must for us to create this a getter function for this, because Solidity creates one for us. So okay, let's just for an example, let me use the setter function that we created to set the blockchain type, the title variable. So let me test out it. So first, I'm going to be calling it for it to be, for us to ensure that nothing is inside it. As you can see, it's returning an empty string because our the title variable is empty. We did not set it to anything. So now let's set it to something. Say block games, and we click transact. So once we do that now, the blockchain state, these are the transaction details. So let me just clear it. And also, so now that we've set it now, our blockchain state should be updated. So to confirm that, let's call this title get again, the title variable again. So you can see that now that it returns block games. And that's exactly what we set here. So this, like I said, Solidity automatically generates a getter function for public variables, and that's it. That's how Solidity works. So let's create a custom getter function. So maybe when we don't want to make this public directly, we just want to make it private or stuff like that. So let's create a custom getter function. So it's very easy to create, just like we did for the setter title. And the only thing we just do here is return the title. Yeah, as you can see that we get an error here. It tells us that we get an error. The reason is because, like I said before, Solidity is statically typed. Everything you want to do in the smart contract, almost everything, you need to tell it what type. You want to return a function, you want to return anything in a function, you need to tell Solidity the type of whatever you want to return. So yeah, what we are doing is that we are returning this blockchain, this smart contract state variable, which name is title, and that's what we are doing here. We are returning title. But what type is it? It's a string, as you can see here. It's a string. So we are not going to be telling it that okay, what we are returning is a string. Returns by using the returns keyword. Then we tell it okay, what we want to return is a string. And we need to pass in, we need to also use this memory keyword again, so that it's going to know that we are not using the, we are not storing whatever we are returning in the blockchain state. It's just during this function execution, and after the execution, you should discard it. So you see, we are still seeing an error. Why? Why is it an error? So the reason we are still seeing an error is because we are not telling Solidity whether the scope of the function. We are not telling it, is it public, is it internal, is it private, is it whatever. We are not telling it. So to do that, like we did above, we just need to add a public, or since it's going to be called by anybody actually. So we add the public keyword of visibility. So you still see again that we still get a warning. Why are we getting a warning? So basically, the reason we are getting the warning is because this variable does not, this function does not update the blockchain. What it does is just take the state variable from here and return it for us. That's the only thing it does. So in Solidity, we have something called we have view, and we have types of functions. We have view, we have pure functions, we have yeah, that's it. So what this means that this smart contract and this function is not doing anything on the blockchain. It's not like taking anything on the blockchain and updating it. What it does is just to take it and return it. So it's a view, it's just viewing the blockchain for us and giving us back the value. It's very it's an easy keyword to understand. What this does is that, okay, what type of function is this? It's a view. What does that mean? It means the function just view the blockchain state and returns what we want it to return. So here we are just viewing this. What we want to view is this thing, is this variable up here. This is the title variable, and what it does is just to return it. So that's why it's view. It's a view. So we also have pure functions. Let me just quickly explain, because we might not be having like a use case where we need to use it in this code. So pure functions, just like view, pure functions does not access anything on the blockchain. It doesn't access the blockchain state at all. So you see that because we named this function pure, we are getting an error here. So if you read the error, function, you see that function declared as pure, but this expression potentially reads from the block from the environment or state that does requires view. So which means that pure function does not even need to read anything on the blockchain at all. They just do whatever they want to do and return the response. So you can think of pure function as they do not have side effects. So basically, they are not altering the blockchain state. They are not updating or setting anything on the blockchain. They might just accept a parameter and return and do some operation and return it, or they don't accept anything or just return. Let's say just return a string like this. So this is basically a pure function. We do not access anything on the blockchain. We are just return this string. It's a pure function, very, very pure. We are not like updating. So basically, that's just about the pure and view. So because we are only accessing the blockchain, we are not updating it. We need to just tell it that, okay, we are just viewing the blockchain and returning this. We are not doing any other thing. So that's why we use view here. So let's save that and come and run and deploy again. So we need to recompile. Let me delete this instance that I have here before. Let me delete this. So let's recompile our first contract. So it's compiling. And once it's compiled now, we can deploy. So as you can see now, you can see the deploy smart contract here. So you see this new function that I just created now, get title. It's a view function. It just returns everything that the blockchain states. So if you call it now, it's going to return an empty string because the blockchain title state variable does not have anything inside it. So it does the same thing as this title. So in some okay, let me set the title to block games 1.0 and transact. So as you can see, let me just clear the output. If you call the get title getter function again, so it should just return block games 1.0. And that's exactly what we are doing. We are just doing the blockchain and returning what we want to return, and that's the title. And also, if you use this generated getter function that Solidity generates for us, so we can just call it. It does the same thing as this getter function. So it also returns block games 1.0. And that's a simple, your first simple smart contract. It's very, very simple. Let's go around it again. So up here, we are we are telling, telling the compiler or anybody reading the code what version and what license we are using, or what license the code is using. So in our own case, we are using MIT. So if you don't want to license your code, you can use unlicensed. And doesn't can, but I'm going to be using with MIT. So then the next line, we are telling the compiler what version of Solidity to use using the pragma directive. Then on the other part of the code is where we create the smart contract. As you can see, we are using this contract keyword. Then the next thing is telling writing the name of the smart contract or the smart contract itself. Then everything inside the curly braces are the smart contract functions, variables, any other thing that we might be using in the smart contract. So then here we are creating a state variable whose name is title. It's a public variable. Its data type is a string data type, and that's it. So then we have a setter function which we are using to set this state variable, which is title. The setter function accepts one argument, and that's the title. Then because it's a string, okay, I'm still going to like talk about this in time. So let me just read. So then we have the public keyword to tell you that anybody, the smart contract is public, anybody can read it, anybody can check what's inside or execute it. Then we also have the get title, which is a getter function, and it's a view function, meaning it doesn't alter anything on the blockchain, it doesn't update the blockchain, it doesn't add or delete anything from the blockchain. It just take the data from the blockchain and return it to us. And we are also like, since, like I said, Solidity is statically typed. Everything we need to do, we need to be telling it what type is this thing. So here we are returning a string, so we are returning a string here. So that's exactly what this means. So if you have any question, you can drop in the chat box. Is there any question?
Okay, no, for now, but just the question available.
Hello, I have one question.
Okay.
I have a question.
Yeah.
Okay.
Okay, there's a question in the chat box, but it's regarding bytecode. Should I read it out?
Yeah, we are still going to like reach the bytecode aspect. So I don't want to like be repeating myself again. Hello?
Please continue. There are no, continue, please. No more questions.
Okay. So so we are going to be creating a simple contract now. Another contract, and maybe that's going to be the last contract that we'll be creating today. And the contract is going to be very simple. It's going to be a to-do list contract. So normally in everything we want to learn in tech, we first do hello world, and we do first code, hello world, and stuff like that. So we did, it's just the traditional stuff to do. So we have this first contract. You guys have done hello world during in the past weeks. So that's why I didn't do hello world again. I just did first contract. And also, it's a common thing to do to-do list. So yeah, that's why I want to be doing to-do list too. Okay. Yeah, so we'll be doing exactly like similar thing that we've done before. So, but in this one, I'm going to be explaining what those that I skipped earlier before. I'm going to be explaining them very, very well. So let's start. So I'm telling whoever is reading it, or if it's the compiler, or if anybody that's in the code that, okay, want to the license that our code is using is this. So I'm using MIC. I don't know, but that's the default for open source. So then we add the pragma directive to tell the compiler the version of Solidity that we are using when it's compiling. Yeah, that's it. So now let's create our contract. So the name of our contract is to-do list. So yeah, now we are going to be like explaining a couple of things that we didn't do before. So like I said, we have data types. So what are data types? So data type is actually a particular kind of data, a type of data. So in programming, a data type is just a data type represents or specify what type of value a variable is going to contain. So if a variable is going to contain a string, then the data type of the variable is a string. If it's going to be an integer, the data type of that variable is going to be integer or int or number, depending on the language. If it's going to be a boolean, or if it's going to be either true or false, then it's going to the data type is going to be boolean. If the data type is if the variable is going to be an like okay, yeah, that's basically what the data type is. It specifies or tells what type of data a variable is going to be holding or storing. So let's in Solidity we have different type of data type. We have the unsigned. Okay, let's start from string. I've talked about string before. So the string data type, we have the string data type. We have the string data type. We have the uint data type. We have the int data type. We have the boolean data type. I think for the basics, these are okay. Then also we have the address. This is very important. Yeah. So a string data type is a data type that it represents a series of characters. So if you have something like A, C, D, B, A, C, A, S, B, D, or anything that is a series of characters like this, it's an integer. It's an integer. I'm sorry, it's a string. Sorry about that. It's a string, not an integer. So series of characters, so can be anything. A series of characters can be anything. Can contain spaces. So let's say hello world. Hello is a string. Just think of a string as a text. 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 Up. Down. This is a string. That's a string data type. Then we also have the uint. Uint data type data types or are integers basically, but they are unsigned, which means, and when we mean that an integer is unsigned, it means it cannot have negative value. You cannot have minus one, minus one, or minus 3 or stuff like that. So basically, an unsigned integer means it's unsigned. It doesn't have a negative, or let's say you can say you cannot say an unsigned integer is there's a positive one and there's a negative one. No, that does not apply in unsigned integers. So an example of unsigned integer is just say 1, 2, 1, 3, normal values, normal stuff like that. Normal integer, normal numbers. So then we have okay, so for unsigned integers we have different bits. We have uint 256, which means 256 bits of integers. We also have uint 32, uint 8, uint 8. This is smallest, I think. And yeah, that's it. So it depends on your requirements. Most of the time we use uint 256, and by default uint is the same thing as uint 256. So if you are using uint anywhere, that means we are still using uint 256. Okay, so let's go to the signed to int. So ints are signed integers, so which means they can have negative values. They can have -1, minus 2000, -3, blah blah blah. They are negative. They can be negative. They can be negative. Not that they must be negative. They can be negative. That's just for integers only. Just int. They can be negative. So example is just -1, -67, blah blah minus, or it can be plus or stuff like that. But basically, if you are using plus, you should be using if you want only plus and stuff like that, you should, and you don't want minus something or something like that, you should be using uint, which means unsigned integers. So then we now say as the same way we have different bits of of unsigned integers here. That's how we have for integers to other integers. To have int 256 and others like that too. So then let's come to boolean. So boolean are basically is either true or false. So that one should not really be hard. It's either you say true or false. That's boolean for you. Then we have address. So address type is a valid blockchain, a valid blockchain address, and they also start with 0x. Yeah, so that's an address, your normal Ethereum address and stuff like that. Is a data type in Solidity. So I think that's clear now. If you have any question, you can still ask. Yeah, so that's it. Also, we also have types like arrays. Okay, let me talk about mapping too before we go. Yeah. Okay. I think as we are going to be talking about other type of integers, other type of data types. But basically, those are the basics. So now our to-do list now, we want we want a couple of things. So we want to be able to create a to-do list, we want to be able to delete a to-do list, we want to be able to update a to-do, and we want to be able to, yeah, that's all. I think we want to be able to fetch a to-do too. Okay, yeah, so let's get into the action. So for us to even have this to-do self, yeah, we need to have somewhere that will be storing it, right? So we need to have that means we need to have some state variables. Like I said before, state variables are variables that are stored in the smart contract storage. They are permanently stored in the smart contract storage, but you can update the content of the variable, you can delete the content, but they are stored in the smart contract storage. Okay, yeah, so I'm going to Okay, I think I should just explain this mapping too. And so we also have type mapping before we also have structs. We also have enum. So mapping is you can think of mapping as an associative arrays. Okay, we also have arrays. Let me add arrays too. I think I will start with arrays. Okay, yeah. So arrays are, you can think of arrays as lists. So in can arrays are just like lists. You can push list of, just think of a list of items. So you can push to the list, you can pop an item of the list, you can do just normal array we have in other programming languages like JavaScript, normal arrays. So that's basically what Solidity arrays are. Although there are some differences, and we are still, if we are going to be like using array in this smart contract, we are going to be talking about all this stuff. So then we have mapping. Mapping is not really not something like that we must have heard before, but mapping is just like associative array, which means basically we have for to create the mapping, we need to have something called key, and we also need to have another called the value. So a mapping basically takes a key and maps it to another value. So you can just say you can say you can create a mapping and say the key of the mapping is an address, and you point it to another value, which is an integer. So for example, to create mappings in Solidity, we do like this. We say mapping, then it takes in the key. What it doesn't take it doesn't take in the name of the key. What it takes in is the type of the key. So we can use any of the type that we've used before, like strings, uints, ints, and the other type that we mentioned before. So we can use, for example, here we can use address to as mapping. So here, for example, if you want to store the balances of addresses of accounts in a smart contract now, most of the time, or most often we use mapping. So we just map an address to the value, which is an integer, and which is an unsigned integer, because the balance should not be negative. Yeah, you should not have a balance to be minus 20 minus 2, 2. So basically, um, a mapping has a key that points to a value. So we are not also going to be saying, we are not also going to just be typing the name of the value. Is the type of the value we are going to be typing also. So here we are going to be specifying the type of the value, which is a uint 256, for example. So then we say, what is it public or private? So let's say public. Then what's the name of the mapping? Balances. So what we do here is, what we did here is just that we created the mapping and we mapped an address to its balance. So let's say there's an address, then we just set the address here and we map it to an integer. So I think I should first show you how to use all these mapping stuff before we continue. Okay, so let's create a function like we did before. Can create a function and say set balance. Then this we need to tell Solidity is the function private or public, so or internal or external. So we are using a public function. So the function will actually update the blockchain state, and that's the mapping here. So to set a mapping, okay, so for this in this function, let's just accept two parameters and say the address, which is, we've talked about this address type before. So the address, which is address, and like I said before, this underscore is just like that Amadi is just a convention. So basically, you can see many smart contracts that they use this format. So basically, most smart contracts use for this format, and there are parameters which are start with an underscore. So then we get the also add the amount as a parameter. So we have int 256 and the amount, which is also the amount here. Oh, okay, yeah, so set balance. So what we are going to be doing in this function is that we are going to be setting the balance here, balance of this address that we are passing here to this amount here. So as you can see here, this mapping has a key which has the type of address, and point maps to an integer, which is the value of the balance of the user. So it points to the balance of the user, basically, just in simple terms. So to set that, we just say the balance, we take the balances here, balances. Then what is the key? The key is an address. So then we pass in the address. So obviously, actually, this thing can be anything. You can name it anything, as long as it's the type of address, because we are mapping an address to an integer. If you use an int here, so it should be telling you that you are doing nonsense here. Okay, let's just add this here first. You see here that it's telling you type uint256 is not implicitly convertible to the expected type of address, which means that you are passing a type of uint instead of passing an address, and this uint cannot just be converted to an address. Like there are some cases where Solidity is smart enough to like convert a type to another type. But in this case, it doesn't make sense for you to just convert a uint, an unsigned integer, to an address. It's not even, doesn't make sense, but it's not even possible. So that's why we are getting this error that we cannot use this uint type instead of using an address type that we are using here. So let's return that to an address. So we pass in the address. Then what we are going to be doing is that we are going to be setting it to the amount that we are passing here, which is the amount. So again, you can see here that the value of the everything in the mapping that we are pointing to in the mapping, or that we are mapping the address to, is a uint, an unsigned integer. So if we try to like change this one to let's say a boolean now, or any other type that's not an integer, you're going to be getting a bool that's not an integer. You're going to be getting an error. See, type bool is not implicitly convertible to an expected type uint, because we are expecting a uint 256 and not a boolean. So basically, we just return it back to uint. So like I said before, uint is like the same thing as uint 256. So if I say uint here, you see I don't get any error. But if I try to say, let's say uint 8, I should get an error. Okay, I think yeah, that's because this uint 8 is actually lower than this uint 256, and it doesn't overflow, even if we use this. So let's return it back to int 256. So what we are doing here, let me explain it again. We are setting the balance of anybody that any address that we pass in here. So also, yeah, that we are passing here, and that's exactly what we are doing here. Balances, then the key here is an address, and that's the address that we are passing here. This can be any name. It's not a must that it should be an address, but it must be a type of address. And the same thing goes to uint 256, which is the value of the the value that this mapping is pointing to. Because here we are mapping this key, this address here, this key, to this value. We are saying that system is just setting it to the value directly. So we are setting it to an unsigned integer here. And one thing you should notice is that it's not a must we order the input this way. You can take this one here like this and say you want it to be here. As long as the type are still the same thing, you still map it. As long as the correct type is still mapped to it, it's going to be correct anytime, any day. So let's compile our smart contract first. How to do this smart contract. Let's come to this one and deploy. Yeah. So we have the first, okay, let's compile first. To-do list.sol to compile. Yeah, that's compiled now. So let's deploy it. So let's delete this one. Don't need it again. So we have it to-do list now. So we have this smart contract deployed now. So as you can see, we also have a UI like we've been seeing before. So you can see that an input is created here. And that's because, like I said, Solidity creates getter for public variables. And that's exactly what it does for these balances. What's the name? Of this balances mapping. So it creates a getter for it because it's public. So anybody can use it. So let's come back there. And as you can see, it has an input. If you notice, the smart contract that we've been deploying before, the public functions that have getters created for them, they did not have inputs. But in this case, we have an input, and that's because the type of our own of this balances variable is a mapping. And for us to read what's inside the mapping, we can pass the key. So it creates this input for us to be able to pass the key of this of whatever balance of whatever account I want to check the balance of. Okay, so let me just do an example first. So we have set balance. So we are going to be entering the amount. As you can see, the amount. So you can see this amount address UN256 and the address here. So they are the type of the inputs that we set in the smart contract when we are creating the smart contract. So let me just come here and select an address here. Yeah, let me switch address. So account, okay, let me copy the new address I'll switch to and then come back here. So what I'm going to be doing here is firstly, let's get the balance first without even having the address existing before. Let's just get the balance. As you see, it returns 0. So the reason you might be expecting that it's going to return maybe node or undefined or stuff like that because you don't have it in existence in the mapping before. But Solidity doesn't do stuff like that. what Solidity does is that it returns the default value, or the base value, of the data type. So for integers, or for uints, the base or default value is 0. So if you have a variable that you created and it's an integer, is an unsigned integer or an integer, the default value is going to be 0, and because that's the base value for integers or unsigned integers. And for strings, it's going to be an empty string. It's not going to be null. It's not going to be undefined. It's just going to be an empty state of that data type. The empty state of a string is an empty string. Yeah, that's the empty state. For integers or unsigned integers, the empty state is 0. Like normally you should have like the empty state of an integer should be 0 now. So also for boolean, the empty state or default state is false. So if you create a boolean variable and you do not set it to anything, by default it's going to be false. So I think we all get that now. So that's exactly what's happening here, because our balance is pointing to an integer, to an unsigned integer. And normally we do not have this key existing before. So that means it's not going to, in JavaScript, let's say in JavaScript now, it's going to be returning undefined for us because we do not have it. But in Solidity, it doesn't do something like that. Like I said, it's just going to return the base value. And in our own case here, it's an integer, it's an unsigned integer, which is 0, which 0 is the base value, and that's why we are seeing 0 here. I get that. So let's do this. Let's set let's put the address here and set the amount to, let's say, 10 or 100. So let's just 100 and let's transact. Oh, as you can see here, I passed in the argument wrongly. I passed in the address to where I'm supposed to pass in the amount, and I passed in the amount to where I'm supposed to pass in the address. That's why I'm getting the error. It says the error sending data, error invalid address, argument address, value 100, which means the argument is an address and we're passing 100. We are passing integer or unsigned integer to an address. So it's going to like reject the transaction. So, and then also for the address, argument is an address, but we have argument is an address. Argument is an unsigned integer, but here we are passing an address. Also, it doesn't conform. So we are going to be getting the error. So let's just fix that and enter the 100 here. We are going to enter the unsigned integer, and then the address, we pass in the address, then we transact again. As you can see now, it works now. These are the logs, the transaction log. So let's clear that again. And now let's come back to these balances. So this here, we are setting the balance of the user here. We are passing in the address, and then we are passing the amount. So, and then we are getting it back. So let's call it here. As you can see, it returns 100. Yeah, that's it. Okay, yeah, so before I continue, I mentioned that by default, Solidity doesn't return null or undefined for non-existing values. So it returns their base value, like 0, empty string, or false. So for addresses, their empty state is 0 address. So 0 address are basically address like that is nothing. So basically it's just it's represented with 0x, then a couple of zeros until the normal length of an address is reached. So that's a 0 address. We are still going to be seeing an example of a 0 address. So I think that's it. So if call this again, like we see, you can see that we have this here. So if we update this, like we are not updating it, we are just resetting it. So we set it to 1000. Then this value should be let's clear the output, and this value should be 1000 now, as you can see. So let's come back to the to-do list contract. So here we are just setting the amount and we are leaving it. We are not like so. What I want to do is like for us to see how to update mapping. Oh, okay. I think we don't do that now. We are still going to be doing it. Yeah, that's what we are still going to be doing this along as we are doing the to-do list contract. So let's talk about structs. So structs are basically are complex data types. They are constructed from the basic data type that we've known before. For example, we know about strings, we know about unsigned integers, about booleans, and yeah, that's it. So struct is made by bringing all of these base or all of these basic data types together and form a complex data type. So to create a struct is created like this struct. Then we type next thing we type in is the name of the struct. So okay, I think we should just be doing this along. So the name of the struct is to do or item. Let's call it item. Which should be an item of the to-do list. So let's be using this as a building block of our to-do list. So as you can see here, we are creating a struct. So basically, structs are not allowed to be empty. So now the next thing we need to do is what's going to be inside the struct. Yeah, so for our to-do list, we are going to be wanting the we are going to be wanting our item to contain a string, which is the contents of the item. Then we also have we also want to have the ID of the item. Also want to have what again? Yeah, I think let's just concentrate into. I don't be getting it. So for us to create a structure. So this basic structure of the struct. So now let's so we have a string. What's the name of the what would be the name now? Title. Let us title. Then so basically this is a basic struct with just one we are just having one item in the struct. So let's add another one, which should be an new int. It should be the ID. So I think this is okay now. Okay. We also have to have a boolean. Yeah, boolean, which will tell us whether the item is completed or not. So completed. Yeah. So this is it. We have our struct. So this is basically how to build the struct. So basically, it depends on whatever you want to store inside it. You can have a struct for a user now. For example, if a smart contract needs it, you can just create the struct and say user struct user. Then you say string the first name of the user, first name, then string last name. So it depends on your use case. So in our use case, I want to just store the to-do list item. So that's why we have this and not, there's nothing much. So then we have enums. So what are enums? Let me think of how to put this. Okay, so enums basically just restricts a variable to have a set of value. Like, so we want to have a variable, and we just want the value of variable to either be um, one of this set of values. Okay, so let me just use let me just write an example. So this has to create an enum. So this has to create an enum. So next, we write the name of the enum. So the name of the enum can be anything. It depends. So for example, let's think of the use case of an enum. So we have okay, let's say status of anything, maybe status of a system or stuff like that. So this basically has to be an enum. So then you can, inside that you can have the values that we want. So the value can either be, let's say, active. It can be active, can be inactive or suspended, or basically anything. So this restricts whatever value that we are setting. We are setting the data type to be this enum. So they must have either of these active or suspended. So if we have another let's say deleted, for example now. So if you now have a string now, if you now have a variable now, so let's create a variable and let's see. Then, so like we all know, variables Solidity is statically typed. We need to tell Solidity what type of type, the data type of whatever we want to or variable we want to create. So we can just say the status, read the name of the data type of the variable status, and you say status status, and say public. Then the name can be status. So basically this is, so anything that this status variable must have should either be this active, suspended, or deleted. So it's convention to make everything uppercase. Let's say active, or say suspended or deleted. So by convention, it's this how most enums are being written. Everything is usually in uppercase. So we either have status status dot active or status dot suspended. So I don't think we need we have a use case for them in this. Okay, yeah, we might have a use case here. Okay, yeah. So a use case here is in this completed one. So you can have instead of seeing this as, you can see actually an enum with status and then status. Yeah, that's it. So basically what we are doing here is that just like our normal uint 256 string, status is now a data type, but a custom one. So you can use it like you use our normal data type too. There's nothing, it's still the same, like just the same thing. So it's just that the values are restricted to either being active, suspended, or deleted. But in our own case here, we want it to be say completed or incompleted, incomplete. And this, I think these are the two I have. So let's move it up here. Yeah, so this is, so this an enum and this is struct. So next, let's create a function. So I think this is all about all this. Let's move them. So let's create a function for us to add to our to-do list. So the name of our function should be will be add item. Then this is it. Okay, so yeah, so we are going to be accepting okay, so our function is going to be public. Yeah, so again, I think that's it. Yeah, so what we are going to be doing next is that we are going to be passing parameters. So when I want to create an item, we want to pass in the title or the content of the item. So then let's name this content. So and there's a string. So what let's pass in the string memory contents. So as you can see, we are using this memory keyword again. Let me just quickly explain what that is. So a temporary is a memory is a temporary place to store data in Solidity. So basically, this string is going to be stored in memory between this the execution of this function. So basically, after this function is after this whole function is called, this whatever is inside this content is going to be discarded. So they are not all when we are passing parameters to Solidity to a Solidity function, and it's a string and maybe an array, yeah, an array. What again? Yeah, not all variables, require this memory keyword. So basically, if you are using an integer here now, int 256, we are not going to be passing. We are not going to be telling it to be to store it in memory or whatever. So there are some. It's only just a select a couple of type of data type that require this thing. So let's say we want to have an array of int, so we need to tell it to store in memory. So if we remove this memory now, we are going to get an error. So it should either be memory or call data. So let's we are going to be using memory. So let's talk about call data too. So call data is just like memory. Like I said, memory store data temporarily, and whenever the execution of the function, whenever we call this add item function, when the function is called, like the whole stuff is finished, the memory will the variable will be discarded, and it's not being stored in the blockchain storage. That's just the meaning. So we have call data too. So call data is similar to memory in that it's it's also temporary, just like memory. It's also temporary. But again, the data is also stored temporarily, but I don't know how to put this. I'm going to do some. Okay, so basically, call data are non-modifiable. Like, I really don't know how to explain this, but just think of it as a similar. It's similar to memory. You can watch tutorials about the difference between memory and call data. It's not really that easy to explain. So let's just continue with memory. So We have string memory, the contents. So what we are going to be doing is that we want to generate an ID for every item that we create. So we are going to be creating a state variable also called item ID. So uint 256 item ID. So let's set it public too. So by default, it's going to be 0, but let me set it to 0. Yeah, so that's it. So we have the item ID. Then also we need a mapping for us to store our items, our to-do items. So mapping. So mapping an ID, which is an integer. So like I said before, we are not mapping a variable name to another thing. We are mapping the type. So we are mapping an unsigned integer to an item, which is struct. So and then it's public. Then which is the name of this it will be items, and that's it. So we are mapping uint 256 to a struct, which is an item, and that's that. So what I'm going to be doing now is creating the whenever I want to add the item now, we need to like create it and add it to the blockchain, to the contract storage. So first, what I'm going to be doing is to update is to increment the ID. So we say increment item ID plus plus. So it's going to add 1 to this. Like it's going to increment it by 1 and update it in the contract storage. Then what we need to do next is to create this create the struct. So we all know that Solidity, we all now know that Solidity is statically typed. We need to tell it the type of variable we want to create. So basically, we want to create a variable of item. So also we are telling it, we want to tell it where to store the variable or where to store the data that we are just creating. So it's going to be stored in storage. Then the name of the variable is item. So item equals item yeah. So then we are going to be passing these details. So here we have this ID here. So you pass in the item ID, which is the item ID that we implemented. Item ID. Then we have the passing the content, which is this one that we are getting directly from the input. So we pass it here. Then lastly, we have the status. So by default, the status should be incomplete unless until we complete it, like we update the item to be completed. So we say the status dot completed, incomplete. Oh, my bad. This should be yeah. So we are going to be writing to the contract storage manually. So we have this now. So to write to the contract storage, we just need to update our mapping. So our mapping is pointing these items. Then the key is an integer. So the same ID that we are using here is going to be our key here. So we are going to be passing in the item ID. Then the value is a struct, which is this. A type of a struct, which is this. And that's exactly what we are doing here. So we just pass in this item here. and that's it. So this is how we add we'll be adding our item to the to-do list. Now that we've implemented the function to add items to the blockchain storage and to the contract storage, we want to be able to get our items.
Right, can you hear me?
Yes.
So please, I need to clarify something. The student is asking, in mapping, what happens if there are two uint 256 in item struct? So let's say the struct there has two uint 256, and then there's a mapping for that. So what will happen with both uint? Will both uint 256 be used for the mapping, or will there be an error?
Yeah, I think this was what the person is asking. Like we have uint 256 here and also have two uint 256 here. Abby?
So like let's say in the struct we have uint 256 ID, and then we have on that uint 256 amount, something like that.
Okay, like we are using different IDs. Like if you are using different IDs.
So let's say we have two uint 256 there, representing two different things. Let's say the first one is representing ID, and let's say the second one is representing something else. So let's say we have this now. What happens?
It doesn't mean you can even store the same thing there. You can store the same thing. As long the only thing is that the variable name cannot be the same. So you cannot just have another ID now. It's going to
like it's actually in terms of the mapping. Will the mapping give an error?
No, the mapping is not going to give an error. Hello?
Okay then.
Yeah, so okay, for that, I think there's no need to do that, but okay, let us continue. So let's create another function to set our to complete our to-do. So we say function complete to-do.
Okay, please, they want more clarity on this. So let's say we have two uint 256 there, according to what I explained before. And now we have a mapping that is mapping a uint 256 value to item. So now somebody is now asking, if it's not going to throw an error, which uint 256 value will the mapping take and map it to an item?
The thing is, you are the one that's going to be supplying the uint 256 to the mapping. So basically, I can just say I can just come here and create another uint 256 here and say it's going to be random ID or any ID is going to be 1, and then pass it here. Then you see, this one is different from no pass here. So basically, we are not checking the value. The only thing we are concerned and that control is the data type. You cannot say you want to be passing an integer and a signed integer to where you are supposed to pass is an unsigned integer. So the value doesn't actually mean anything. The thing is that is the data type that you are passing, is it correct? So if you are passing,
I don't think you are getting the question. Let me explain it again. Can you hear me?
Yes, I can hear you.
What they are saying is, see this uint 256 now.
Yes.
If you check the mapping there, we have mapping uint 256, right? And we are mapping it. Yes, we're mapping it to an item.
Yes.
We're mapping it to item, right? Now let's say we have two values of uint 256. Let's say we have uint 256 ID, and then we have uint 256 amount. So now in this case, we have two uint 256. Now, which uint 256 will the mapping take and pair to item? If it's not going to stand error, then in what order will it pick it?
I got what you're saying. You are not. You can pass any rule into 256 as long as the value, as long as the data type you are passing is in 256. But the thing is, if there is an already, like if you are, if the reason I'm using an ID is because our ID is going to be unique, number one. So we have before we pass in any ID, we are updating, we are incrementing the last ID by incrementing it here. So that this new ID that we are going to be passing is going to be unique. It's not going to be colliding with an existing ID. But in the case where you are using this amount and you are like want to be passing it as this key here, you are not going to be getting an error. But it's a simple logic problem that if someone already have passed that amount before, so your own amount that you are just passing now is going to be overriding the one that the other person have passed, have set before. Do you get that?
Yes, very clear. Please continue.
So it's not as long as the data type is correct. That was just a logic error. So it's going to even cause like maybe cause users to be overriding other users items in your smart contract because you are using the amount. Someone might use 1,000, maybe someone to use 1,000, and my own 1,000 will override the 1,000 of the previous person. And anybody that uses another 1,000 amount after me too can override my own. But if you are using the ID, it should be unique. It's going to be unique. So my own ID cannot be the same as the last person ID, and the next person ID cannot be the same as my own ID. So that way it is safe. But it must be UINT, UINT 256. Also, it's not a must this key should be UINT 256. If you are using a string here, you should be passing a string here, not an ID. So it all depends on the data type that you are using, and doesn't depend on the content. As long as the data type is correct, it doesn't concern Solidity whether you are passing the wrong value. It's your own fault, and it's going to probably cause a lot of damage in the smart contract. Okay, so you can say that we're having an error here. That's because we're having an additional field there, and we are not passing it here. So if I just say, let me duplicate this item ID here, the error should go away. Although we are not passing an amount, but we are still passing a UINT 256. You get? That's why the error left. So if you are trying to pass, let's say content now, we are passing a string instead, we are still going to be getting an error saying you cannot be passing a string to where we are supposed to be passing the UINT 256. So it doesn't concern Solidity what's the value of your data type. Is data type correct? That's what it's concerned about. Yeah, so let's complete to do. Yeah, okay, so to complete our to do now, we are going to be needing the ID of the to do that I want to complete. So we are going to be passing the ID here, UINT 256, then taking the ID. So I'm going to be adding underscore in front. So then it's going to be public, so anybody can call it. And what I'm going to be doing is just updating it directly. I'm not going to be checking whether it exists or not, because even if it doesn't exist, we should be getting the base value, like the base value of this. If a struct, if a value in this mapping, which the struct does not exist, we should be getting the base value. This one will be 0, this one will be an empty string, and this one will probably be completed. I'm not sure about that one. Yeah, okay, so let's just update it directly. So once we update, we want to complete to do now. So to complete the to do, we just say get the items. So we pass in the ID, then we say dot. That's how we access it. Dot. What do we want to do? We want to complete the status to set completed. Status equal to status dot completed. So basically, this is just what we are going to be doing. We are just going to be setting the status of the to do of the item to be completed. So let's create another function for us to check whether it has been should not be to do, should be an item. So let's create another function for us to check whether an item is completed. So we say function complete is completed. Yeah, we pass in the ID to int 256 ID. They're going to be public. Then we just return items. Then we pass in the ID, the status equals. So basically, this is just to compare. It's a comparison operator to compare whether two values are the same. So we are going to be checking whether the status dot completed. So what we are doing here, this function doesn't update the blockchain, doesn't add into the blockchain. So it's a view function, and it returns a boolean. So we're having a boolean because this is going to be is a comparison, and it evaluates to true. It evaluates to true. If it's not completed, it should return false, and if it's completed, it should return true. And that's it. I think this is all we need to do for our smart to do this smart contract. Add item, complete item, and check whether an item is complete. I think that's it. So let's run and deploy. Let me switch back to the first. Okay, right there. So let me delete this one before. And let's compile how to do this data so okay, we just compiled that. So let's deploy to do this smart contract. So let's deploy that to let's clear the output. Okay, so we have this now. So our to-do list is basically empty. So like I mentioned before that if you pass an inexistent inexistent key to the items mapping, it's going to return just the base values. So in this case, let's check what's going to be returned here. So as you can see, for us it returns ID 0, then the content and empty content, then the status it returns 0. So basically, basically how this works is how this enum works from the front end is that this one in the smart contract you can access the enum by saying just status dot the value of the enum that we are looking for. But on the front end or wherever you are using it, this will be 0, this will be 1, and if we have another one, this will be 2. If we have another one, this will be 3. So this will be 0, this will be 1. So because we are passing an inexistent to-do list item ID, which is 0. So we are getting the status giving us 0, and by default, it's going to be mapping to the first item in the enum, which is this enum here. This value here is going to, the data type is the enum that we're creating here, and by default, it's going to be pointing to this first enum value. And on the front end side, whether you're using Web3, JS library, or whatever library you're using, you should be getting 0. And if the value is this one, you should be getting 1. And if you have any other one, you should be getting 2. If we have any other one, this one should be giving us 3 and stuff like that. Just like arrays 0, 1, 2, 3. That's how that works. So, oops. Okay, so let's come back to our smart contract. So let's add an item. Item here and check 1. You should be getting ID 1, content, less solidity, and status 1. So if you come back here, you can see that the status here is incomplete, and that's exactly what we are doing here. So like I said before, this one will be 0, this one will be 1, and the status here still gives us 1. That means our logic is correct. So, and the content, less solidity, then the ID should be 1. Then let's add more items to the to-do. Okay, first let's check whether the item is completed or not. So checking that or passing the ID is 1. So it's not completed, it's returning false. So let's try completing it by calling this complete item function. Let's pass in the item ID. So let's clear this again, and let's check whether it's completed again. So this time it's returning true, as you can see. Then if we try to fetch the word item again, now be 1. That should be giving us ID 1, content, then solidity, then the status should be 0, back to completed. So like you see that the completed is at the 0 index of the enum. That's why I'm guessing 0 here. Yeah, so we can add more items to the to-do list. Say search Google read some books. Read some books. And that's so I think these items are okay now. So let's check the items in the smart contract. So this item 1 should return the one that we had before. So 2 now should return the one that we just created. So ID of 2, then the content should be search Google, then the status should be 1, which is incomplete. Then we have the third item that we created. This one should be ID of 3. The content should be read some books, and status is 1. So let's complete this one too. The item 3. So let's complete. Okay, let's see whether the item 3 is complete. So it returns false. So let's complete it. So it's done now. So let's check again whether it's completed again. Yeah, so it's completed. So I think yeah, that's it about this to-do list and smart contract. Yeah, I think that's all now. So if you have any question, can you know. Thank you. Hello?
We can hear you.
Yeah, I'm done.
Okay, that's
Okay,
fine.
okay. Let me quickly deploy this to a live network. Okay, so basically, I'm going to be writing. So we've been working with our local node since morning. As you can see, these are the logs from everything we've been doing with transaction call, contract call, so everything that we've been doing. So let's terminate the node and let's deploy our smart contract. So with hardhat, we can deploy a smart contract with just some few lines of code and we are done. So let's create a file there called deploy.js. So what I'm going to be doing is that we're going to be importing the hardhat package const HRP equals require I'm sorry, I just want to create a VS Code settings. So I have the demo installed, so it's interfering with my need. So you actually do not need this, it's just my own configuration stuff. I need to disable demo. Yeah. So okay. So now we're able to use that one. So require hardhat. So we'll create a main function. So this is an arrow function. So and outside of it, we'll be calling the function. So it's going to be an asynchronous function because we'll be doing some async stuff inside there. So let's get the contract factory. So the contract that we are deploying is the to-do list contract. So we can say to-do list equals to await HRE. The meaning of HRE means hardhat runtime environment. So basically, hardhat injects your settings, the configuration that we set here is going to inject it into the into the environment whenever we are running the an hardhat command. So by using the hardhat runtime environment, then dot artifact dot get oops, get dot status dot get contract factory. So let's pass in the name of the contract, which is to-do list. To-do list. We are saying then let's deploy the contract. So const to-do list is actually easy to deploy the contract with others. So equals to await to-do list dot deploy. Then we say await to-do list dot deployed. So basically we are just here, we are just ensuring that the smart contract has been deployed. Then we can console the log the contract address to-do list contract address Then asking this here. To do list dot address. Yeah, so let me quickly explain what we are doing here. So I'm just importing the add art package and assigning it to a variable called HRP, which means add art runtime environment. Then what I'm doing is I'm getting the contract factory, the main contract package, the smart contract, which is this. I'm getting it. Then basically the name, whatever we are passing here should be the name of the smart contract to do list. Then so basically I'm just using the convention, which is to use a Pascal case for this. Then here I'm deploying the smart contract here and assigning it to a camel case instead. So here we use a capital T and here we use a small t. So we are deploying it here. Then here we are just ensuring that the smart contract is deployed. Then here what we are doing is that we are just logging the smart contract address. So if you are deploying a smart contract that has a constructor and you need to pass a constructor to the smart contract, what you need to do is just to enter the arguments that you are passing to the constructor here. Whatever arguments, you just take it to arguments, enter the arguments, and you'll be fine. So our smart contract does not have any constructor, so we are fine with this. So let's deploy. So to deploy with hardhat is very, very easy. Just some few lines of code and run the command npx hardhat run. Then what do we want to run? The script / deploy.js. So script / deploy.js, then enter. Scripts. I think deploy.js. I should use this. I'm coming. Let me just check what's happening. Does actually work? I'm not sure. Let me just do this and copy this part. Okay, let me run this example. I think that's a problem with hardhat because this will actually work because we are deploying from inside the script deploy.js, and even I'm testing it with the one that comes with hardhat. It's still like giving the same error. So I don't know. Let me try on the network. Okay, yeah, it's working now. I think that was because we started the node before. Okay, yeah, so to-do list contract address, and this is the address to our deployed smart contract on the hardhat network. So I want to deploy to a live network, right? So let me quickly show you guys how to create, how to deploy to live network. So we can use, we have nodes, what do you call it, node, hosted nodes with Alchemy and Infura. So we can use Alchemy and also Infura. So it depends on whatever I want to use. Alchemy API. So then we also have Infura too. So I'm just going to be choosing any one of them. Let me just go with Infura. So we're using Infura. You can use Alchemy too. So I have a test project already. So project settings. I'm going to be copying the address to what I use on link by. So this is the node URL that we need. Are you there? Okay. Are you guys? Can you guys hear me? Hello?
Hear you.
I hear you, please.
Node URL that's provided by Infura. So for this, okay, let me just quickly show you how to create the product. So this get to dashboard. Let me open up the lights mode. So you create a new project by clicking on this button that's at the top right corner. So you create, you enter your project name and your product. So in our case, it's Ethereum, then your project name. But I already have a project which I use for tests every time. So which is test project that I just used. So I've copied the URL. So let's add networks. Then inside the network, we add the name of the network. So we are using link by. So link by. Then inside this, we are having an URL which will point to our link by URL. So we also need an address that we'll be deploying with. So I'm going to be using MetaMask, my so let's quickly look for that. So what I'm going to be doing is that I'm just going to create another account. No, I'm not creating another account. That will take some time. So let me just switch to link by and looking for one of the test addresses. The test it. Okay, we have this too. So let's request from there's something called there's some service called faucets. So basically, you can just if you need test it to test your dApps or your decentralized applications on the test network, you can go to those faucets and apply for some for some test tokens for you to test your applications. So I'm going to be using it by going to select from by, then pasting my wallet address. Okay, I'm going to connect to my MetaMask wallet. Yeah, so I have that. So we send it. Okay, yeah, so that's waiting for confirmation. So it takes some time for us to um for that to happen. So bear with me. So I'm just going through. I'm just trying to use the faucets for those of us that have a problem like that, have a problem with requesting um, test tokens. So with this, I think it should be clear now. So you can actually click on these transactions to check their status. So having this, I'm going to look at this. So I think it's not in mind. So it's taking a lot of time. So basically, but that's how.
So
So I'm.
Faucet has not been working since this evening.
Oh wow. So I'm going to be switching to Kovan instead then. So I have some funds on Kovan. I just wanted to use that. That's want to like to show how to request funds from the faucets. So since I'm using Kovan, I'm going to come back to my infra account and come to my project settings again and copy my Kovan and like switch to Kovan, then copy my Kovan node URL. So instead of using it by here, I'm going to be using Kovan. Then this is Kovan. Okay, yeah, so then the accounts. So at the accounts, you pasting the private key. So this is a test project. I'm just going to copy my private key from MetaMask. So yeah, that's it. So now we have this setup, so we can deploy to Kovan. So to deploy the Kovan now, we just need to specify whenever we are running the deploy scripts, we need to specify the network instead. Then so we say network Kovan. Then there was a typo there, so network so Kovan. So the network will be passing must actually be in this list of this object of networks. So I have Kovan. So I'm passing Kovan now. So it's going to be using this account. So to do this contract address, so if you copy this now and come to Kovan, Kovan.etherscan. So let's go to the Explorer. So that's the Kovan block Explorer. So then the address that the smart contract that we just deployed. So we have that. Yeah, so as you can see now, the address is on the Kovan network. And this is the first transaction where we create the smart contract. And as you can see here, it was 33 seconds ago. And also the contract creation transaction. So basically that's how to use hardhat and the basics of Solidity in general. So I hope you guys enjoyed this today's live session. And if there's any question that you want me to answer, you can ask now. Thank you.
Thank you so very, very much. I'm sure everybody enjoyed it. So like I said, if there are any questions, please you can raise your hand and just raise your hand so we can allow you to speak. There are no questions for now in the chat box. So do you have any question, anybody? The coordinate, the person teaching is by developer, yeah, and I am Victoria, assistant. So basically, they're just saying thank you in the chat box. So I don't think there are any questions.
Someone is raising the person's hand.
Oh, okay, yes. Okay, Ehube, please unmute and speak.
All right. Good evening. Guys, sorry, hello guys. I think we are in different time zones. Yeah, so I was trying to set up that Ethereum remix thing or that you did previously, and I landed on the page that it's telling me to connect to a network to deploy, and I've tried clicking the connect buttons and it's not working. So all the times you landed there, it seems like you just did something and all of a sudden it was working for you. So I don't know what to do from.
Yeah. Do you have hardhat installed?
Yeah, I didn't get what you said.
Do you have hardhat installed?
Yeah, I have installed hardhat.
Just in your project root, run npx hardhat node. Let me show you the command here. npx hardhat node. Then you click enter. So it's going to, what this is going to do is that it's going to spin up a fake blockchain for you. Then you copy this and the URL to the blockchain node that was spin off by hardhat, and then you copy it. Then you come back to this your remix, run and deploy. So then you paste in the okay, let me disconnect so I can show you that. You paste in the address, the URL that you just copied, okay, and then you connect. You can try it and let me know whether it works.
Okay. Okay, all right. Yeah, it's working now. Thank you very much.
All right.
Thank you.
Okay, please, any other person with question? Everywhere you can put down your hand.
Yeah, if there's no question now,
Somebody is asking if hardhat can be installed on phone.
I'm not sure. I'm not sure. But to install hardhat on phone, like there are a lot of things going on in the background. You are running a blockchain in the background, and running that on phone can do a lot of things. But normally you should run it, since I have also installed Node.js on my phone when I was learning Node.js. So with that, you should be able to install hardhat on phone. But the problem is when you are running it, your phone might crash. I don't know. You are running a full blockchain node on your phone.
Okay, we have another question. Somebody is asking, so is this the kind of UI we were asked to create?
No, the UI that you'll be building in your own task is going to be like an interactive UI. This UI is provided by Remix for us to like quickly interact with our smart contract before deploying to the blockchain network. Or you can deploy to the blockchain network too and connect with a node. So it's just a simple UI for us to interact with our blockchain, our smart contract functions, and also like do some things with it. That's basically what that does.
Okay, so we have one last question. Okay, we have one last. So does truffle work this way too?
It works in a similar way, but Truffle doesn't have a built-in blockchain on its own. You have to install Ganache. Also, with block and with Truffle, we can't. It doesn't like. It doesn't take. It doesn't bring in. It doesn't run a blockchain automatically in the background, like the way we just deployed our smart contract without running a blockchain node on our own. So with hardhat, you need to have Ganache running before you can do that.
Okay, so somebody is asking, if we want to connect this to-do list contract to the front end, how do we call our functions?
So basically, you'll be using some libraries. So we have Ethers.js, you have Web3.js. Also, okay, you need the smart contract ABI too, and to interact with the smart contract. So before I continue, let me quickly show you the API here. So when we compile our smart contract, hardhat is going to generate a folder for us, and this is the folder, the artifacts folder here. So inside the artifacts folder, we have some other. We have three folders, but we don't need the other two now. The only one we need are the contracts, and then inside that we have the contract that we created. We have the first contract.sol, the greeter.sol, the to-do list. So for the to-do list, this is files. So this one we really don't need it now too. The only one we need now is this. So for the ABI, this is the ABI. So the ABI starts from here and ends where the array ends. So here the array ends here. So this is the ABI. So this everything about the ABI. You need it on your front end to interact with your smart contract. So ABI, the meaning of ABI is application binary interface. So it has a set of functions that your smart contract has on its own end. So you can easily call the smart contract method from your front end application. And also we have the bytecode. So this is the BIN that what they call it, BIN. So this is it, the bytecode. So basically, the EVM, the Ethereum virtual machine, it doesn't understand Solidity directly. So that's why we are compiling our code before deploying. The only thing the EVM understands is the bytecode. So we compile our Solidity code, and this is the compiled version, which gives us this bytecode. And this is the bytecode that will be deployed to the blockchain network. This is the thing that's deployed to the blockchain network, not your actual Solidity code that is being deployed, but this bytecode. This actually was being deployed to the blockchain network. Yeah, I think that's it.
Okay, thank you so very much. So we don't have any other questions. Okay, somebody is saying an error keeps showing up when I try to stage my file and commit to GitHub. How can I transfer my code to like VS Code? I usually see multiple files when you guys are working on VS Code.
Yeah, I don't understand the question.
In your role, can you review?
That's a GitHub.
I think it's a GitHub. Yeah, it's a GitHub question.
You can solve that on Discord. You should send me a good on Discord.
Yeah, that would be better. So yeah, several other questions will be attended to on GitHub. on Discord, I mean. Thank you so much, Bright Developer. Yeah, this section is recorded and to be uploaded on YouTube for everybody to watch again. So that's it for today. Thank you everybody for attending. Thank you, Bright Developer. We enjoyed this section.
Thank you.
Sorry, Taiwo. Taiwo, don't worry, we'll attend to your questions on this Discord, please. I didn't notice that.
Yeah, if it's something that you can answer, yeah, I think you should just.
He said I avoided all his questions and I can't find any question. Okay,
Yeah,
he's asking about batch. He said, does batch run like our normal CMD or PowerShell?
No, I think bash is different from CMD. I'm not sure about PowerShell. It's different. CMD is for Windows. I think bash can run it on Linux and Unix-based operating system.
Okay, so Taiwo, is that okay? Okay, so I think that's all. Thank you, everyone.
No, it's not a must to install bash. If you are using Windows, you can use your Windows command to accomplish all that we've done here. There's nothing special. We are not running all the code that I'm running are not like native to Linux. They are just npm commands. You can install npm on Windows too. So if you install npm on Windows, you should be able to run all those commands that I run here too. That's just it.
Thank you so much, everybody, for coming. Thank you, mentors. That'll be all right.
I guess so.
Okay,
Yeah,
thank you so much. Good night.
Yeah, good night.